Hello everyone, welcome back to my channel Code with AKJ. Today is day 10 of solving Geeks for Geeks problem of the day, and today's question is number of pairs. So the question says given two positive integers arrays ARR and BRR, find the number of pairs such that x power y is greater than y power x, where x is an element from ARR array and y is an element from BRR array. Coming to the example, we have given two arrays and we need to find the number of pairs such that it satisfies this particular condition. And from this example, the answer would be 3. The pairs would be 2, 1, 2, 5, 6, 1. So the brute force solution would be to directly compare each and every possible pair x, y, where x is an element from ARR and y is an element from BRR, and counting how many times x power y is greater than y power x. So generally this approach would have a time complexity of O of n cross m, where n and m are the lengths of the ARR and BRR respectively. So I have drawn an example. From this particular example, the number of pairs would be like 2, 1, 2, 5, 1, 1, 1, 5, 6, 1, and 6, 5. So we'll check this condition for each and every pair and we'll see if that particular condition is being satisfied or not. So here 2 power 1 is greater than 1 power 2, so we'll take it as a valid pair. Same goes with another each and every pair, and we'll see and observe that only 3 pairs satisfies that particular condition and remaining does not satisfy, so we get the answer 3. So the code of this brute force would be to iterate over these two arrays and check this particular condition and have a count variable which counts the number of pairs which satisfy the particular condition and will return that particular count. Here you can find the code of the brute force solution where we have taken a count variable. We have iterated through two arrays ARR and BRR, and we have checked the condition. If this condition satisfies, we increase the count variable and finally we'll return count variable. So here for small values this would compile successfully, but for the large values of x and y this would give a wrong answer. So let's see if it accepts the solution or not. So let's compile and run. Let's submit. As you can observe, on submitting it gives wrong answer. It mostly succeeded for most of the test cases as it was for smaller values. When it comes to larger values it gives a wrong answer. So we need to optimize this particular approach as it takes O of n cross m time complexity. The optimized approach would be to simplify the equation. Here's how. Let me explain. So here I've given us a gist of how we can approach the given solution. Here's where the maths kicks in. Here we can transform the problem by taking the logarithm on both sides. So here's the given condition. We need to take log on both sides, which converts y log x greater than x log y, and we'll divide this both sides by xy, which gives log x by x, which is greater than log y by y. This means we can reduce the problem to comparing log x by x with log y by y for each pair. First we'll calculate values of log x by x for every element in ARR array and store in vector x. Secondly, we'll calculate values of log y by y for every element in BRR array and store in vector y. Next we sort the both vectors. This allows us to efficiently count how many elements in ARR satisfy the condition for each element in BRR using binary search. Here we use upper bound to find the values which are greater than or equal to that particular value in Y array. Finally, after finding the number of values in X array which are greater than Y array, we'll add those values and we'll finally return that value from the function. So let's code this approach. Here we have taken the size of both vectors as m and n. We have created a vector of float of both sizes m and n, and we have calculated both log x values of both vectors and stored in vectors x and y. We have sorted both vectors x and y, and finally we have calculated upper bound in x for each and every value of y. So if we find a value in a x vector, then we'll deduct that value from the size of the y value, and finally we'll store that value in answer variable, and finally we'll return that answer variable from the main function. So let's compile and run if it gets submitted or not. So let's submit. As you can see, this problem is submitted successfully. So the time complexity of this solution would be O of n plus m log n, as we are sorting both vectors. The space complexity of this code would be O of m plus n, as we are taking an extra space of vector of float. If you like this video and my explanation, please give it a like and subscribe to my channel for more such videos. I'll see you in the next one. Thank you.